What's up guys, and welcome to this video tutorial or walkthrough of the 2018 IEB maths exam. We're going over question 2, which has to do with number patterns once again, and summations and a couple more things as well, but yeah. Okay, so it says given that the sum of 108 times 2 over 3 to the n from n equals 1 to x, determine the first two terms. Okay, so nothing too difficult there, some free marks. So this is A1. So all we're going to do is we are going to substitute into the equation n equals 1 and n equals 2. So for the first one, T1, we're going to say that's equal to 108 times 2 over 3 to the power of 1, which is equal to 72. And T2 is equal to 108 times 2 over 3 to the power of n is equal to 2 this time, and that gives you 48. Therefore, T1 equals 72, T2 equals 48. We can box that answer right there. And we get ourselves 2 marks. Okay, part 2 says if we have that summation is equal to 520 over 3, determine the value of x. So determine how many times we have to add these things up for it to become 520 over 3. So what you're going to do is you're going to get T3, okay, and all you're going to do is that's 108 times 2 over 3 to the power of 3 this time, and that equals 32. And if you add these all up, that's still less than 520, so you go on to the next term, which is T4 equals 108 times 2 over 3 to the power of 4, and that gives you 64 over 3. And if we add T1 plus T2 plus T3 plus T4, we will get 520 over 3. Therefore, x equals 4. So we have to add the first 4 terms for us to get the sum equals 520 over 3. And we get 4 marks for that, which is quite generous. Okay, so the next question, question B, says hollow plastic hemispheres are created such that each successive one fits into the previous one. Okay, that doesn't really matter. What we've been given is OB. So this is the radius OB, OD, and OF, and we've been given that it's 21, 3, and 3 over 7. Determine the sum of the outer surface area, okay, which is the shaded region, of each of all such hemispheres created by continuing the pattern to infinity. Okay, so basically we want to get the sum to infinity. So first of all, we need to see what kind of pattern this is, right? And it's focused on the surface area. They've given us a hint. The surface area of a hemisphere is equal to 2 pi r squared. Okay, and that I assume is going to be this shaded region. So the equation that they've given us is for this shaded region here. It's a hemisphere, surface area of the hemisphere. Okay, so what we need to do is we start off with our areas. So area 1 is going to be 2 pi, and this is going to be 21 squared. Area 2 is equal to 2 pi, and this time it's going to be 3 squared. Area 3 is going to be 2 pi times 3 over 7 squared. Okay, so what's happening is we're taking the radius and we're multiplying, so radius times 1 over 7, right? To get from 21 to 3 is 1 over 7. To get from 3 to 3 over 7, that's once again times 1 over 7. Okay, so what's happening is we're timesing this by 1 over 7. But remember, that's still being affected by this squared sign. So actually, for this geometric sequence, and it is geometric, for this sequence, we know that the common ratio is equal to 1 over 7 squared. Okay, I'm writing that because it's easy to see that it's 1 over 7 is what's happening in the bracket. So each time that r, the radius, is being multiplied by 1 over 7, but it's being squared because of this formula, which is equal to 1 over 49. Okay, so the common ratio is 1 over 49. Okay, so this is r, so this is our common ratio is equal to r, therefore r is less than 1, so it is a convergent series. Okay, because r is less than 1, between -1 and 1. So therefore we can go to our formula sheet, and if we go to our formula sheet we can say that the sum to infinity is equal to a over 1 minus r for r is between -1 and 1. Okay, that's on the formula sheet. So now we just need to fill out this equation. So that's a, so this is going to be a is our first term, and that's equal to a, so that's going to be 2 pi over 21 squared over 1 minus 1 over 49. And if we plug that into our calculator, we get that the sum to infinity is equal to 7203 over 8 pi, which is equal to approximately 2828,6, and the units that we were given are centimeters, so it's going to be centimeters squared. Okay, so that's really it to this question. The important part here was understanding that your common ratio isn't just 1 over 7, but it's rather 1 over 7 squared, and that square comes from this equation right here. So yeah, and we get 5 marks for that, and we total out at 11 marks for this question. It's quite a nice question, nothing too difficult. I hope you guys understood it, and thanks for watching.